Welcome back. What we are going to be learning today are three new properties: power of a power, power of a product, and power of a quotient. You should have already learned in previous videos the product and quotient properties, as well as the negative and zero properties. If you have not watched those yet, please do so now, for this is going to be a little confusing if you don't know those four properties ahead of these. So the first one we're going to talk about is power of a power. That's just saying that an exponent raised to another exponent gets multiplied. So in this case, see how our base with an exponent on it got raised to another exponent, so they're kind of stacked on top of each other. When that happens, you're actually just multiplying those two exponents together, and you'll see examples of that later. Power of a product property says, all right, whenever you're multiplying, keyword product, whenever you're multiplying your bases together and you have an exponent on the outside or a power on the outside, you just go ahead and distribute that on in, give it to both the A and the B. So everything inside the parentheses has to be given that exponent. Same exact thing with power of a quotient. You need to take that outside power, in this case m, and give it to whatever is inside the parentheses. And in this case, you're just giving it to the two terms, but they're being divided instead of multiplied. So you still have to give it to the a and the b, but there's a division sign between them instead of multiplication. So let's look at some examples. We have m to the third n squared, all of that being raised to the fourth power. So the first thing you should think is, can I simplify what's inside the parentheses at all? So always try and get that down to its simplest terms before you deal with the number on the outside. So m cubed n squared cannot be simplified. So I'm going to go ahead and use my power of a power rule after I use my power of a product rule. So we're kind of combining the two. Power of a product says take this number on the outside and go ahead and give it what's on the inside. This is really going to be m to the third to the fourth and n squared to the fourth. And then our power of a power rule says, all right, when you got two exponents kind of stacked on top of each other like that, go ahead and multiply them. Well, 3 times 4 is 12, and 2 times 4 is 8. Oop. So m to the 12th, n to the 8th. The next one, we have 1 divided by 2 to the third power. Again, can we simplify anything in the parentheses before moving forward? Well, 1 divided by 2, that's just 0.5, but I don't want to deal with decimals right now, so go ahead and distribute that 3 inside. There's nothing else to do. So this is really 1 to the third divided by 2 to the third, and that can be simplified further if you so choose. That's 1 over 8, because 1 to the third is 1, and 2 to the third is 8. Our third example, again, can we do anything inside the parentheses before distributing the 2 on the outside? In this case, the answer is yes. So we can go ahead and multiply our large bases to begin with. -2 times 5 is -10. And then we have like bases are x's. So x to the fourth times x to the -3rd. Well, here, whenever you're multiplying like bases, you must add those terms together. So add your exponents. 4 plus -3 is 1. Then we can distribute the 2. So I'm going to jump ahead a little bit here. I know I'm kind of revealing all. So we had -10 when we multiplied -2 and 5. And we had x to the 1 power, x to the first, when we added our exponents on our x's, the 4 and the -3. The 2 was still on the outside. Since we simplified everything that was in the parentheses, we can go ahead and distribute. So I distributed the 2 to the -10 and the x. So -10 squared, x squared is my answer. You could simplify this even further and say that this turns into 100x squared, because -10 squared is 100. Our fourth example here, we have only 2x inside the parentheses, and that can't be simplified. And you have to do exponents before you do multiplication in this case. So I'm going to ignore this 5m squared for just a moment and deal with this 2x to the 0 power. So think back on our previous video, what does anything to the 0 power equal? Well, that's just 1. So all of this right here actually turns into 1. I'm going to go ahead and highlight that. So this whole chunk right here turns into 1 because it's all raised to the 0 power. So this really means, what is 5m squared times 1? Well, that's just going to be 5m squared. The last one, we do have things that we can simplify inside the parentheses first. So there's a lot of steps that you could do in different orders here. So I have one way that I'm going to do this. You could do this in quite a few different ways. So I'm going to just divide those 3's first. 3 divided by 3, that is 1. You could have used the exponent rule as well, the quotient property, which says anytime you have like bases, in this case 3, you can subtract the exponents. So that's 3 to the 0, which is still 1. Then we can deal with the m's. We have m to the negative 2 divided by m to the 5th. So go ahead and use your quotient property rule that says take your exponents and subtract them. Negative 2 minus 5 is negative 7. I'm going to reveal my answers a little early. I apologize for that, but I'm going to explain what happens. So I just showed you that we got 1m to the negative 7 with that 2 still on the outside. But now we can distribute the 2 because everything on the inside has been simplified. So the 1 in the front's not super necessary, so you can even ignore that if you want and just pretend this is m to the negative 7 squared. But I'm going to leave it just for the sake of the fraction at the end. So 1 squared is still 1. M to the negative 7th squared. Our power of a power rule says anytime you have two exponents stacked on top of each other like this, multiply them. That's why I got negative 14. Then we have our negative rule. So anytime you have a negative exponent, to make it a positive, change its location. Right now this is on top of a fraction. So we're going to take the m to the negative 14th and bring it to the bottom. The 1 stayed on top, and that's how we have 1 divided by m to the 14th as our final answer. Again, there was multiple ways you could have done this. So this last slide that I have here, I just want you to try these for yourself. I'm going to reveal the answers in just a moment, so make sure you pause the video. These ones are tricky. There's quite a few steps in it, hence why my answers are really long, grayed out bars. So I do have a lot of this equals this, which equals this. So know if you're taking, 3, 4, sometimes 5 steps to solve it, that's okay. So go ahead and pause the video and then check the answers. Best of luck.